Following data refers to the job P, Q, P, Q, R, S, which have arrived at a machine for scheduling. The shortest possible average flow time is dash dash dash. Okay, so job PQR is given and their processing times are mentioned. Okay, so job P, Q, R and S. Okay, and processing time in days, and processing time in days. Okay, 15, 9, 22 and okay. So there are the many rules, but best rule for the shortest possible time with the shortest possible time, that is your SPT rule. Okay, shortest processing time, that is your shortest processing time. SPT rule, okay, in which we sequence the machines according to their processing time, means least first and maximum at the last. Okay, so from this we can get the sequencing, that is your first minimum, that is your Q. Okay, minimum, that is your Q, then S, then P, then R. That will be your sequence. Q first, then S, then P, then R. Okay, now let me go for the processing times. Okay, now let me go for the next table. Okay, jobs, that is your sequence Q, S, P, R. Okay, Q, S, P, R. Are you getting this or not? Yes, Q, S, P, R, and their respective processing time 9, 12, 15. 9, 12, 15, 22. Okay, and let me go for on the machine in and machine out. Okay, machine in and machine out. Okay, and this is your processing time, machine in and machine out. Okay, 0 to 9, 9 to 21. Okay, 21 to 36. Okay, 36 to 58. Okay, are you getting this or not? And job flow time. Okay, job flow time for each jobs. Now let me go for the job flow time for each jobs, that is your 9, 21 job flow time, 9, 21, 36, 58. Okay, that is your individual job flow time, but what they are asking about the average job flow time. Okay, what they are asking about average job flow time. Okay, now let me calculate the total job flow time, that is your cumulative sum, that is your 9 plus 21 plus 36 plus 58. And how many jobs are there? 4 jobs are there. Yes or no? 4 jobs are there. So average flow time, so average flow time, which you will get 930 30, and you will get 31 as an average. Okay, 31 days, that will be your answer. Okay, 31, that will be your answer. Okay, so thank you for now. Two models P and Q of a product earn profit of rupees 100 and rupees 80 per piece respectively. Production times of P and Q are 5 hours and 3 hours respectively, while the total production time available, that is your 150 hours. Full stop. For a total batch size of 40, maximum profit, the number of units of P to be produced. Okay, P to be produced. Okay, so let me go for the first, the formulation of the problem. Okay, two models P and Q, that is your decision variables, so we have to maximize the profit according to the question. So 100 rupees on each unit of P and 80 rupees on each unit of Q. Okay, which is subjected to, that is your objective function, that is your objective function, subjected to constraints are given, subjected to, let me go for the first, that is your 5 hours plus 5 hours for P, 5P plus 3Q. Okay, time availability. Okay, so it should be less than or equal to 150. Okay, and the total batch size of 40. Okay, P plus Q should be less than or equal to 40. That is your given constant, and P comma Q greater than or equal to 0. Okay, now let me go for the graphical method for this. Okay, now because two decision variables are there only. Okay, so let me draw first line. Let me draw first line for first constraint. Okay, if we, that is your P and that is your Q. Okay, that is your P and that is your Q. Okay, just a minute. Okay, P and Q, that's it. Okay, P and Q. Now let me take Q is equal to 0. What you'll get? P is equal to 30. Yes or no? So let me take 30 point here. Okay, if P is equal to 0, what you'll get? Q is equal to 50. Okay, that will be your first line or not? That will be your, by joining these 2 points you'll get the first line should be less than or equal to. Okay, now let me go for the second line. So here we have the point 50, here we have 30, the 40 and 40. Are you getting this or not? Now at the 40 and 40. Okay, so 40 here and 40 here. Okay, so what will be your feasible region? What will be your feasible region? That will be your feasible region. Okay, now let me take 3 points, and that is your origin A, B and C, and let me, this point will be equal to, by the graphical method, 15, 25. Okay, you'll get this point is equal to 15 and 25. Okay, now let me go for the profit. Let me put this value in the objective function. Okay, so ZA is equal to 100 multiplied by P is at point A. At point A it is 0. Okay, multiplied by 0 plus 80 multiplied by 40. Okay, so you'll get 3200 rupees profit. Okay, now let me go for the point ZB. So 100 multiplied by 15 plus 80 multiplied by 25, you'll get 3500 rupees of profit. Okay, let me go for the ZC. Okay, ZC. Okay, ZC, here it is. So 100 multiplied by 30 plus 80 multiplied by 0, so what you'll get? 3000. Okay, so maximum profit, that will be your 3500, and the value of decision variable at this maximum profit, that will be your 50. Okay, that is your asked in your question, the number of units of P to be produced, that will be your answer. Okay, so P is equal to 15 units. P is equal to 15 units. Okay, so thank you for now. Thanks.